All right. When we last left our intrepid heroes, they were finishing the answer to part A, which was if the rocket sled leaves the ramp um, after having these forces on it and does not hit the bird, how fast is it going 2.5 seconds after spot B? Okay, so now we've got part B, which says what is the max height from the ground of the rocket sled? Now you'll notice that both B, C, and D do not reference that they don't hit the bird, but this one doesn't matter because it said the bird hit at the peak, so this would be the moment right before, so we're not yet in collision yet with the bird. Now, as we look at our picture, one thing that's important to note is that basically, obviously the rocket is going to rise above its original position. This should be delta y while going up. Okay, but it obviously doesn't start on the ground. Okay, so we have this. How can we get that particular guy right there? We'll call that height of ramp. Let's not overcomplicate this thing. We've got one side of the ramp. We've got an angle. So let's go ahead and scroll over here to the side and just do some basic trig. We know that that part of the triangle is 400 meters, quarter of a mile. That angle is 17 degrees. And so the height of the ramp is simply going to equal 400 meters sine of 17 degrees. Now, because that's a quarter of a mile, take that into consideration when you get your answer. That should be 116.9 meters. Now, this is the time where a lot of students ask me, or maybe even before this, how do I know at 400 meters which part of the triangle it specifically is? How do I know that's not the horizontal distance? And I think the easiest way to answer that question is just ask yourself, what makes that most sense? You know, if you're talking about, say, a driveway where, maybe your driveway's on a hill, okay, and just strolls down. Nothing's going to be 17 degrees. That would be a ridiculous driveway, but any sort of slope whatsoever. If I said, how long is your driveway, what does it make the most sense to give you? And that would simply be the hypotenuse. Giving you the horizontal distance if you traveled, underground does not make the most sense. So when it says a 400-meter long ramp, kind of just take into consideration what makes the most sense as far as where that 400 meters is at. That being said, on a problem on a test where obviously, kind of matters, if you're having any troubles, you can always ask me to clarify what is the issue. All right. So the rest of part B should be relatively easy because we just need to get delta y. The main thing to remember is this. We came down here and we did a bunch of two-dimensional stuff down here, but this final right here, this final velocity, you can see is not at the peak. This spot of C right here is not the spot that we're looking at. So we can use these exact same initial numbers and we can use the same acceleration, but obviously time is out and all these finals are out, so don't accidentally combine stuff that doesn't go together. That being said, I will definitely steal those answers from the previous one. Velocity in the x was 46.1 meters per second. That is super messy. Let's try that again. 46.1 meters per second x hat. And velocity initial in the y was 14.1 meters per second. Okay. Of course, we know that the acceleration in the y is negative g. And since it says the peak, I know that velocity final in the y is 0, because the velocity up here in the peak, and this will be important for part C to remember, is entirely in the x. It's not entirely 0. It is still going at 46.1 meters per second to the right, but in the y it's definitely 0. Since I've got 3 variables here in the y, I'm just going to go straight to delta y. And that's going to be velocity final in the y squared equals velocity initial in the y squared. Let's just go ahead and fix that mistake that I just made there. Velocity initial in the y squared plus 2a delta y. Velocity final is 0, so that cancels. Subtract that over. Squared equals 2a delta y. So let's go ahead and divide by 2a is equal to delta y. Let's go ahead and plug our numbers in. negative 14.1 meters per second. Notice that that negative does not cancel because of the square, because it's not inside the parentheses, but that's okay. Because if I've done this correctly, you'll see my negative g is, in fact, going to cancel that guy right there. Plug all that in, and you should end up with about 10.1 meters. It's not actually that high up in the air beyond what you started, which makes sense because I kind of commented on this last time. It's traveling 14.1 meters per second in the y direction. That should get to the top in about 1.4 seconds. And it's going somewhat fast, but it should only cover 10.1 meters. Why is that so much smaller than this 116? Because we went a quarter of a mile in order to get up that high. But our final answer of how high a person is, as you can see over here, is this height of the rocket plus that delta y. Let's come right back over here. Let's go right underneath here. Okay, let's go the height at the peak is equal to the height of the ramp plus delta y, which is going to be that 116.9 meters that we got from Trig, plus the 10.1 meters that we got from 2D motion. Add those up and you get that the total height is 127.04, but let's just go 127 meters. Again, commented on this last time. Rounding is going to cause us to be really not quite the right answer, not quite the same answer, but pretty darn close. If you're pretty close to 127, you probably got it right. And that's the end of part B, and I'll be back for part C.